All right, so let's compute the difference quotient. For f of x, and let's see, let's just do this. So I know this might be a question come up. Let's just do it this way. Okay. Compute the difference quotient for f of x equals x cubed minus 4. Finish up with this one. It wants us to compute that f of a plus h minus f of a over h. And what that means to do is we've got three parts here, if you will. I've got f of a plus h. I got f of a, and then the bottom is a lot easier. It's just h. But here's what this means. Isn't this just goes back to our function notation? How would I compute f of a plus h? Well, that's the input value that I put in for my x. So to compute this, I just plug in a plus h for the x. So it'd be a plus h cubed minus 4 is what this piece would be. Now this piece, a little bit easier than that, because what does this piece want us to do? So I've got minus then the f of a. Now, let me put this f of a is just saying input a for x. So that's going to be a whole lot easier, a lot nicer looking thing. If I put in an a for x, that's just a cubed minus 4, isn't it? Now the bottom is just h. That's not a function notation. That's just a number or letter, variable. It's h. So that's the beginnings of this difference quotient. If you have never done one of these, that's the way this begins. And notice again, around f of a, I did put parentheses because there's going to be some sign changes in there. All right, now, I guess there's different ways you could do this, but here's one way we can do this one. Usually when we got a binomial squared or binomial cubed, we're going to want to cube that out. There's different ways we could do this one, but let's just cube that one out. Okay, a plus h cubed. That just means a plus h 3 times. Okay. All right, so if we do 2 by 2, so it'll be a times a is a squared. We've got an HA and another HA, so I've got 2 HAs or AHs. And then I've got an h squared when I multiply those two. And then if I multiply a third one, a plus h in, a squared times a is a cubed. A squared times h, that's a squared h. Then I do the 2a times 2ah times a, it'd be 2a squared h. Then 2a times h is 2, doing these two, so it'd be 2ah squared. And then h squared a, let's just say that's ah squared. And then h squared times h is h cubed. There are some like, those two are like, so I've got a cubed plus, that'd be 3a squared h's. And this, those two, that'd be 3ah squareds. Those actually are like there. All right, so if I cube that out, I get this. A cubed, so this right here becomes a cubed plus 3a squared h plus 3ah squared plus h cubed. That's what that becomes. Then the minus 4, and then distribute the minus, so it'll be minus a cubed plus 4. All that is over h. With me so far? I wanted to do one of those cubes too, just to show you. If you cube it out, that's what you get. All right. But then the beauty begins here. Because usually on these difference quotients, you get a lot of things cancel out. And we do have some things cancel out. Not a lot, but some. What cancels out here? 4s and a to the third. Because I've got an a to the third, I've got a minus a to the third. I've got a minus 4 and I got a plus 4. So those are going to 0. That leaves me these 3 on the top. However, you might notice there's some more canceling can go on here, because what about these 3 now? Well, they all have a factor of h, don't they? They got an h. So it'd be 3a squared there, it'd be 3ah there, and h squared there. So on the top, if I factor out an h comes out, the h's cancel, and all I'm left with is 3a squared plus 3ah plus h squared. Okay. And so it doesn't go any further than that, but it does clean up pretty nicely, especially imagining what we came up with here. That's works out pretty well. All right. Any questions on that? Is everybody okay on that, stepwise? Any problems? Okay. All right. Good deal. All right. Let me give you